Welcome to DefenseTech TV, a new series focusing on the technologies, strategies, and partnerships shaping the future of national defense, presented by HII Mission Technologies. I'm your host, Francis Rose. The conversations you'll see on today's program come from DefenseTech Live, a forum HII Mission Technologies hosted for government, industry, and academia to discuss these critical issues. You're about to see the first program in this series. Speed to the warfighter is the Pentagon's most important goal right now, according to the department leadership speaking at this event and many others. Today, you'll hear from leaders in the Office of the Navy CIO, the Naval Research Laboratory, the Mitchell Institute for Aerospace Studies, HII Mission Technologies, and many others on driving speed for decision advantage. First, a look at air power in the age of speed.
Brigadier General Houston Cantwell, U.S. Air Force, retired as Senior Resident Fellow for Air Power Studies at the Mitchell Institute for Aerospace Studies. It's great to see you. Thanks for joining me, sir. The discussion around autonomy is very robust here and more broadly in the national security community right now. But we talked a little bit before we went on the air about the fact that this is not as new as people maybe seem to think the autonomy discussion is. Is it, sir?
No, it's really not. The United States Air Force has certainly been working on this challenge for probably decades because we want our advanced aircraft to have these types of capabilities. And those aircraft are both the unmanned aircraft as well as the manned aircraft. And it's difficult to be able to advance these technologies and get them incorporated in a way that's useful to the warfighter. And that's really the challenge right there.
Yeah, I think that's maybe the most insightful part of the conversations we've had on this program and at this event is, rather than thinking, how do we get these cool new things, the integration discussion seems to me to be more important and more prominent now than I've ever seen it before. Is that a fair read, do you think?
Yeah, absolutely. Yeah, the first unmanned aircraft, the Air Force even went so far as to call them remotely piloted aircraft because they wanted to really hold back on a lot of the automation, because they're unmanned, they're doing their own thing, and you want the pilots to be hands-on as much as possible. And now we're seeing in the next iteration of unmanned aircraft, collaborative combat aircraft, we're unleashing the automation and letting it really have an effect on the battle space.
What are the underpinning principles to make sure that that is done well and serves the warfighter well and not just serves the service well?
Yeah, I think the underpinning would be, as you walk through the kill chain, and I know a lot of your audience isn't, it's deeply or steeped in the kill chain, but the find, fix, target, track, engage, assess, that entire chain has to be, and until now, we've had humans do every step of that to be able to effectively close that kill chain. Now we have to figure out, where can machines automate, speed up certain parts of that process. We actually have some weapon systems that can automate the entire thing, but we put artificial stops in that kill chain to allow humans the opportunity to impart their wisdom, their judgment on very complex situations.
Mm-hmm. And it strikes me that most of that conversation has revolved historically around, are we ever going to let a machine push the button? And as you lay out all of those steps in the chain, that's probably not the right conversation, or it's probably not the only conversation that we should be having. Is that fair to say?
Agreed. Like I said, we have systems, some missile engagement systems, whether it's the Aegis cruiser that the Navy operates. But you see what's going on in Ukraine, where there can be times where there are literally hundreds of these small targets coming at an airbase. Human operators will not have the decision space to be able to decide which ones to engage and how to engage them. So in some of these mass attacks, you're going to have to go full automation if you really want to stop these large attacks.
And I imagine what's possible now that wasn't possible historically is the ability for a defense system to anticipate or tell, that one's a machine, so I can kill that one. That one's human, so I need to flag that, and another human has to make that decision.
Yeah, I actually think that's still a work in progress. I think that a lot of our ability to identify friend or foe, a lot of those capabilities are still being developed as we speak, because the United States military has just not been engaged in these large mass attacks. Even in the Persian Gulf right now, a lot of the attacks that are going on with our bases are few numbers of, whether it's cruise missiles or ballistic missiles or drones, coming at our bases.
Your colleagues that are still in uniform tell me on an ongoing basis that data is the most important thing that they have to help them understand all of these things, and it connects all of these systems together. What is the concern on your part, if any, about that data network, that data foundation potentially being an Achilles heel, an opportunity for an adversary to take advantage of?
Yeah, two concerns. Number one is we are so good at stovepiping our data. And so even though in a very complex air operations center, you have all these data flows coming in, all relevant information, some more relevant than others, the right information's got to get to the decision maker at the right time. And that's where our challenge has become. How do you filter that? Because it's overwhelming, the overall amount of data. But then secondly, as we move to our data links and our unmanned systems that need to stay tied to some type of a decision maker, those data links become so vulnerable. And a lot of the data links being used in combat are oftentimes commercial networks. So the Ukrainians are using the Russian cell phone towers, and you've seen in the news that Elon Musk's Starlink has been used by many military systems. And so how do those civilian systems integrate, and how do we manage that as a society moving forward?
How many of those questions, from your view as an officer, how many of those kinds of questions are tactical, and how many of those questions are philosophical?
I think you touch on both. When I was doing a lot of my research on counter UAS over the last few months, I was astounded at how involved Elon Musk was in national security. Here is a American citizen, a very wealthy and influential American citizen, but getting directly involved in how the conduct of the Ukrainian war was being conducted, a war that the United States hasn't even formally declared a part of, yet his decisions on what Ukrainians and the Russians had access to when it came to Starlink had a direct impact on the battle space. And those are policy level decisions that will only continue to grow bigger and bigger as we move forward.
How does that influence the way that someone in your former shoes, with your former brass, thinks about how he or she needs to implement policy or execute strategy?
I think that our senior officers, our generals, are going to continue to wade into both of those sides. You know, it's the world that they operate in. And as technology on both the commercial side and the military side become more and more intermixed, it's going to be a reality.
General, it's great to talk to you. Time goes by very quickly. Thank you for being here today.
Thank you.
John Bell's the Chief Technology Officer for HII Mission Technologies. It's great to see you. Thanks for joining me. What's on the landscape right now, or maybe over the horizon, that people in the services should be thinking about today that you're really excited about, John?
Well, I have to say, the most compelling thing that has really caught everybody's attention that we've been watching for some time is the evolution of autonomous and unmanned systems, particularly in the way that we're able to use autonomous systems for manned-unmanned teaming. So we've always had this idea of, drones going out and taking pictures, but now that we are really evolving into unmanned systems across all the domains, not just air, but also surface and subsurface, the ability of those systems to augment the manned systems and to do the dirty jobs that nobody really wants us to have to do with people in the loop, or to do the repetitive jobs that allow us to use our manned forces so much more effectively. And the evolution of artificial intelligence to supplement those capabilities, of course, is transformational. It has created a new foundation for all of the technologies that we deploy for the warfighter. And it really, again, is augmenting the human in the loop. And so now we can have a human on the loop, monitoring and watching what's going on, providing more of a commander's intent to an autonomous system that then has a certain degree of freedom to operate as needed to achieve the objectives of the commander and support the mission.
I'm struck by the conversation the evolution of the conversation around autonomy in exactly the way that you just described, because we've gone very quickly from a discussion about autonomy and what role does it play to how do we integrate autonomous vehicles into the fleet, the inventory, and how do we use them most effectively in the kind of environment that you just described. From an industry perspective, how do you think about that and try to lay the groundwork for helping the services solve problems?
So that's, I think the integration is really the key point, and it's something that I've really been pushing from my perspective as CTO for HII, that as we are moving towards an acquisition environment where we want to buy things off the shelf and really make much more effective use of commercial capabilities, uh, that leads to a challenge with integration because we're now buying products that really weren't designed from the ground up to be integrated either with other products or with our manned forces. In many cases, because they were commercial, they weren't even designed for Department of War applications. So in Department of War over the years, we've recognized we have a huge integration challenge, even with systems that were bespoke, exquisite systems built for the Department of War. So as we bring in these commercial products, we have an even bigger problem with integration. It's a real challenge. So the answer to that is multi-level. One of the most basic foundational things that we here at HII promote is modular open systems architecture. And that's a big word, but what do we really mean? We mean break the system down into pieces, and then for each piece, have an open definition of how that piece has to interoperate with all the other pieces. Yes, you can still have your secret sauce inside your particular sensor or piece of the system, but the way you interoperate with the other components of the system, that should be public, openly available to the other pieces of the system so that we can interoperate effectively. Another big area, though, that we're seeing evolve for integration and interoperability is the use of artificial intelligence, and particularly agentic AI, where we can have AI robots effectively that work on our behalf. And because they're AI-based, they have access to so much information about the systems that need to interoperate. So now instead of having to hire a whole team of people to go delve through a lot of technical documentation and write software to make this system talk to that system, we can simply deploy an AI agent who already knows what those interface specs are and can almost on the fly build that interface and do that interoperability communication on behalf of the human without having to build a large, complex interoperability solution.
The dialogue around AI is, especially in the department, is very robust and very deep. So I'll let that for other folks to discuss, but I want to go back to MOSA in the time that we have left. For a long time, my perception as an outsider was that MOSA proponents in the building and in the industry were kind of pushing the rock uphill. And now that's changed. What helped you guys get the rock to the top of the hill to now come down the other side with such momentum as it has today?
I think it's been one of those things that took a long time to get started, but with the demonstrable success of MOSA, people look at it and say, oh, okay, not only do I see that it can actually work the way it's intended, it also doesn't really hurt us. Within industry, there, of course, has always been a certain degree of reluctance to embrace MOSA because of that secret sauce. We don't want to give away all those special capabilities that we've developed ourselves, and frankly, we'd be crazy to share it with other people, but to share how it interoperates and how it interfaces. So as an example, one of the products that we are developing is the Enduring High Energy Laser for the Army. And one of the reasons we've been successful with that product is we went into it from day one with an open systems architecture approach. And we said, hey, we will connect with all the different vendors who develop all the components of this laser system. And we will share those interface specs with the government and with those vendors. And that gives us a lot more flexibility in selecting vendors and making vendors be competitive with each other and allowing us to put together a system that really works to achieve the mission without it having to be our own containerized solution that nobody else can get into.
John, it's great to have you here. Thanks for joining me today.
Thank you. It's been a real pleasure.
Captain Randy Cruz, Commanding Officer of U.S. Naval Research Laboratory. It's great to see you here. Talked on stage about something I think is really interesting. Autonomy, obviously very sexy and very top of mind for people in the force, but you talked about using autonomous vehicles in much different ways, I think, than most people are talking about them today. How so?
Thanks for having me. The Naval Research Laboratory does a lot of work, huge portfolio, everything from the ordnance and the fight itself, but sometimes the fight is bigger than just the transaction of weapons. One of the things that we're all looking at is sustainment and readiness of ships, and how we apply autonomy systems to that. We've got this program called the Insertable Stock for Inspection Systems. For ships to go out to sea, they would normally have to undergo days and weeks of inspection of their ballast tanks. What does that mean? That means you have to empty it out and then get someone certified to go into this gas-free environment and make sure it's safe to go in there and see if it needs to be repaired. Well, using some autonomy and taking a picture and some algorithms, we're able to not have to empty the tanks fully, inspect it and see if, yeah, we need to sideline this boat and fix it, or no, it's ready to go and put it back out to sea, making that turnaround much shorter, making these ships available for sea. Autonomy is more than just the fight. It's the whole spectrum, getting ready for the fight, the sustainment, but the fight itself as well.
So it strikes me that we're at the same point with autonomy that maybe we were with AI a year ago or 2 years ago, where people are starting to think about how do we solve a problem, and then autonomy may be one element of that, instead of going about looking actively for ways to use AI, autonomy, whatever. It sounds like that's kind of where you are. Is that a fair read?
That is very fair. The Patriot scientists at the Naval Research Laboratory, they like to take a problem and figure out how to solve it, not necessarily engineer a current solution, but tell me what the problem is. The problem is I got ships that are stuck in port for a long time. Well, how do we, let's drill down where that problem is and then fix it. And that's just one example. I'm sure there's many others. I don't want to steal the thunder from my 2,500 Patriot scientists that do all the work. I'm just the face that tries to market for them, which is quite honestly, I was going to say this, we don't have a technology problem with the laboratory, we have a marketing problem. So opportunities like this to share what we're doing or invite industry to help us solve these problems, we're all about it.
How do you align the work that you do to the broader Navy agenda, CNO's fighting instructions, the policy that comes out of the offices, the Pentagon? How do you translate that to what you're doing at the lab?
Well, we absolutely subscribe to it. So Admiral Caudle's fighting instructions, what he released earlier this year, talks about the sailor first. And I will tell you, I treat our scientists at the laboratory like sailors. They're very critical to how we operate. And then we've got the foundry, the organization that makes this happen. And the laboratory and the stuff that comes out of there is definitely part of that and part of the fleet. And then eventually helps us succeed in the fight. When you look at the fighting instructions, he'll talk about tailored offsets. And that's when we talk about robotic and autonomous systems and other technology areas. And the laboratory is doing every kind of technology from seabed to space, plus cyber and quantum, understanding that today's fight is going to be decided in that space and cyber domain. We just talked about the multi-domain fight that we're in. And while you look at the maritime space or maritime sea, land, space and cyber, that space and cyber, that's the new ground, if you will. We've gone past the days of the Continental Army lining up your folks and shooting, muzzle after muzzle. We're no longer playing checkers. We're playing chess.
The alignment is critical in a number of different ways. How does working that alignment, especially when it sounds like you just have to fine tune it. It's not a broad shift in the way that NRL does business. How do you go about making sure that you stay on track as time goes on?
So the laboratory is a working capital model, first of all. It's like a company. And so people will fund us to do specific work. And then there's a small portion where we come up with our proposals. Whichever one that falls into, it's got to be directed towards maritime application, aligned with the Office of Secretary of War's critical technology areas. He's listed 6. We'll do those 6, and then we'll do even further. One of the things that he doesn't mention is that of undersea. And as a Naval Research Laboratory, we're definitely invested and interested in what happens in undersea and making sure we've got technology that's going to help us fight that fight. So we always go back to the commanding doctrine and the guidance from leadership to make sure that we're aligned.
What is ahead for the service broadly, and what are the areas that the service that you expect to see focus on, that you're working now to try to deliver awareness, capability, and so on?
There are a couple of areas of interest that are garnering extra attention. That of resilient networks. When we talk about multi-domain, there's going to be a lot of data that's being pushed on different networks and different constellations. And if we're going to rely on that data, one, we got to make sure it's accurate. So what is our feeding mechanism to make sure that we always talk about the OODA loop, the observed portion. What do we have? Is it accurate? Is it still relevant? It's going to be a lot of data. And then do we have the networks to support that? We've got at the laboratory the Center for High Assurance Computing Systems that comes up with all kinds of cool things to make sure that that's happening. And there's still more work to be done. But everything in cyber and quantum, we don't do quantum computing, but we'll do quantum sensing because we want to make sure that we can navigate, and then also alternative PNT solutions in the quantum world. There's a lot. I know we don't have enough time, but I invite you and your watchers to join us at the laboratory and see what we've got going on, and perhaps even join us.
We have less than a minute left, but you used the term constellation that I think is striking. It implies in my mind the ability of warfighters to transmit information to and share data with each other rather than having it have to come back to HQ. Is that the model that you're going for?
Absolutely. We understand now that there's going to be a lot of information. So getting that information to the right hands, the decision makers, in the right amount of time is going to be critical. So making sure the health of those networks, those constellations is important. So we launched this GOSAS satellite last April to make sure that it's going to be looking at that. We've got this TREX program that was transitioned to the Space Force that allows the management of antennas across the world to collect that information that's coming from space. It is a rich environment to make sure that we've got the right data, the right time, to the right people to make the right decisions.
Grant Hagens, President for Warfare Systems for HII Mission Technologies. Grant, thanks for joining me today. A lot of discussion here around autonomy and AI in particular, especially the integration of autonomy into the services inventories already. And people keep saying time after time after time, what isn't getting a lot of coverage is the people piece of that. From your perspective, how should the services be thinking about the people piece of all of these technologies and the way that they're using them?
Sure. So it's really, so autonomous systems really enable a warfighter to expand the breadth and reach of their capabilities. So, one soldier now can control unmanned underwater, unmanned surface. You could have a robotic dog carrying a sensor. You could have an unmanned ground vehicle. And that one operator now can surveil and see a lot more, and then, if needed, use those capabilities on the battlefield.
Mm-hmm. All of those pieces of equipment that you just described are carrying sensors, and that means more and more data than organizations have ever seen before. What's helping them curate that information to know what's important and to know what they need to take action on and to know what they need to save that might be useful to them at some point in the future?
Yeah, that's where you're seeing a lot of the AI come into play. So, we actually, for the Navy, the Army, Air Force, across the DOW, we have written and deployed big data platform, which is managing petabytes worth of data. And we're putting AI tools on top of that, basically to make sense of the data. Not to overwhelm the end user, because when you have one soldier that controls a whole host of unmanned systems, you're going to get operator overload. So those AI tools are really hey, this is most important. And it's almost like you're a strategic supervisor now, where you're not getting down in the details and say, you go do that, you go do that. It's, hey, this is my number one priority. I need to focus on this. This is number two. This is number three. Hey, you work on that. You work on that. And when they say you work on that, it's actually a unmanned system. Mm-hmm. So it's really changing the role of the human in the loop and giving it much more capability.
And how do you underpin how do you build the infrastructure that underpins all of that so that that person that is using all of those pieces doesn't need to worry about how that infrastructure is working and doesn't even see it, really, doesn't even know about it?
Yeah, so there's two things. Number one, you have to make everything interoperable. So then you get in, and you heard a lot of discussion today on MOSA.
Mm-hmm.
So exposing those APIs, those interfaces. So if I'm building something and I'm company A and I'm building another thing and I'm company B, they can come to the battlefield and work together and feed one overarching system that can take that data, process the data, and present the data in a manner that the warfighter needs.
I think the most encouraging thing that I've heard today is that industry is on board with MOSA. The department's on board with MOSA, especially at the leadership level. The challenge is at the mid-level in the department to get folks to understand you really have to be persistent and you really have to make sure that you're getting from each of the vendors the information that you need and the IP that you need to be able to share that. You think that's a fair?
I think industry is getting there. We've always championed that. I mean, you look at us, we're a shipbuilder. We've been integrating things forever. We don't build the combat systems on an aircraft carrier, but we integrate them. So we've been doing it for a long time. Other companies are getting on board because you have to, to play in this game, you're going to have to do it. On the acquisition side, you really have to think about it when you're putting out the request for proposal. You build it in the requirements, because if you don't, traditionally, you get a vendor lock, and companies may, it may benefit them to lock the customer in. So if you don't think about it up front, it kind of migrates to a vendor lock situation. So you really got to put that into the requirements, and then we have to come up with solutions that show that interoperability, reach out for the best in breed. And, if we have a component that we think is best in breed, it's on us to give them the best capability.
Mm-hmm. What have you found to be the best practices in demonstrating that to the department to understand, to basically send them the message, we get where you're going and we're on board, and this is how we're demonstrating we're on board?
Well, like our Enduring Hell program, from the get-go, we were talking about the illities, be it the interoperability, the producibility, and then that open architecture. So that really, and the customer, that's what they wanted. They didn't want a closed system that if something broke, they had to wait 12, 14 months for another system. So we had been working with them, same with our other customers, letting them know, hey, this is where we want to go. I know you want to go there. Let's work together and see if we can get there.
It also sounds like kind of the subtext of what I'm hearing is that the services are getting better at telling you this is my problem rather than giving you a long list of requirements that you have to fulfill to get the contract. Is that a fair?
Absolutely. And you see that, come with what you have, show us what you have, and then we'll make a decision. So you see the OTAs, the CSOs, it's bring capability, and then we'll evaluate that. We won't go down a long list of requirements. And if you don't hit this one, you don't meet the next milestone, you don't go on, that prolongs a program. If you come with capabilities like most of the commercial space works today, you're bringing the capability. If you like it, you might want some tweaks to it, but you're going to put it in the field and give it, because it advances the warfighter's capabilities, and then you can build on that.
We have about 30 seconds left. What's over the horizon that you think people in the building should be thinking about today that will affect them 12 months out, 24 months, 36 months out?
Well, AI is all over, and that capability, there's a lot of concern that'll take away jobs. The way I see it is now you have, be it a software developer, that one software developer is now a team of 50. You have agents that can build more capability faster, and that's what you're going to see. You're going to see more capability getting into the hands of the warfighter, and it's going to come quicker, and it's going to be a whole new ball game. If we talk about what's going to happen next year, it's almost like Moore's law. you can only go out about so far because you're going to see capability just grow and grow and grow.
It's great to talk to you again. Thanks for joining me today.
Thank you.
Art DeLeon's Director of Strategic Spectrum Policy for the Don CIO. Welcome. It's great to have you here. A lot of discussion here about the need for speed in everything. How is that demand signal from the service personnel affecting the spectrum world, the landscape that you live in?
So in today's environment, one of the key pieces that we traditionally work in, not only the tactical, but operational and strategic components, is that we operate under static frequency assignment processes. And those frequency assignment process means that I reserve a frequency for 24 hours, but only use it once out of those 24 hours and maybe for 15 minutes at a time. That static environment has to change. Creating maneuver space across the strategic spectrum takes essentially maneuver space in order to move us towards what are those automated connections that allow us to build those same interfaces that we enjoy today with cellular devices, Wi-Fi type systems. If we're provisioned and we have access, we should be connected, whether we're at an installation here at home or an installation abroad or in a tactical type environment where now we just turn on our systems and I've been provisioned and authenticated on the account and I can communicate with anybody in the world because we built those accesses to build maneuver space in that spectrum.
An expert told me recently that spectrum is sometimes taken for granted because the theory is it's always been there, but I imagine that's changing in the kind of environment that we live in today.
Yes, I would say that spectrum in today's environment is the visible backbone with everything that we do, from communications to electronic warfare. Those capabilities are critical to delivering the message end to end, regardless if we're in a tactical environment or in the United States flying a drone. Those components are essential in order for us to deliver that bandwidth.
You said on stage, we don't have a frequency problem, we have a bandwidth problem. What is that? And how do we go about mitigating that?
So right now, the frequency problem is because the frequency is mine and I don't want to share it. And if we look at it from that aspect, I'm only using a discrete frequency assignment that allows me to maybe totally do voice. But if I look at it from a wideband standpoint, I don't think we have a frequency problem. We have a bandwidth problem. And by essentially integrating those frequency assignments or those static assignments into a wideband network, I can make the most effective use of that bandwidth by essentially allowing the network to decide the best path to deliver the message.
Who has to do what to allow you to do what you just described?
I would say that right now the culture is really the number one problem because our culture has been built off of that 1950s regulation that says that this service is only identified for aeronautical mobile or terrestrial mobile, or it's just for fixed locations. And that basis is my method to argue that this is my bandwidth and you can't utilize it. And that basis and that idea has to change in order for us to really move forward and to what I would describe as spectrum on demand. Spectrum on demand allows us to build that maneuver space using automation and open architectures to get us to where we need.
You just kind of anticipated my next question, which is this a situation that's been overcome by gains in technology? Is it something that's been overcome by demand signal or some other reason that the change is possible but hasn't yet happened?
So digital technology in today's environment is critical. And the things that we used to do in the 1950s, we were dependent on noisy tube technology, which most of our regulations were developed under, has created the problem that we have today because those regulations were used to essentially protecting systems that were used to receiving noise, and large noise amplifiers into a system creates an unavailability of communication systems. But in today's environment, digital really tunes out those capabilities and allows us to get closer and closer together without creating interference to other systems. So I would say the difference is really the regulatory standard that's keeping us from moving forward.
Technologically, what are you able to do now with the bandwidth that you have that maybe you weren't able to do in the past or weren't able to do as much of, that kind of thing?
So in today's environment, if I were to describe what are the major differences, and I would start in the early 1990s, and we described the MRSAT terminal as our first generation of SATCOM type capabilities. And it was really form factor for specific capabilities, voice and data, and that was all it was used for. In today's environment, I can build an interface from our terrestrial communication systems to our aeronautical and space, with the seamless architecture that allows me to essentially authenticate on the fly and not have to request permission from a manual process or a human in the loop, which I think that's really where we're going, is how do I minimize the human in the loop to build that seamless connection from end to end, so we have a systems types connection that gives the greatest bandwidth in the world to deliver communications to anybody in the world, to include deliver unmanned systems, video capabilities, and make decisions on the fly.
So when you, that description helps me to understand more why the regulatory environment is important to you, because it sounds like the technology exists to do all the things that you want to do all the things that the warfighter will need to do at the tip of the spear. And getting from here to there is the challenge. Is that a fair read on my part?
That is definitely a fair read. And if I describe it, we have 149 countries that we coordinate with on a day-to-day basis, and they have their say on how they would handle communications inside of their country. But if we change the standards and how we build interfaces from end to end or system to system, those ideas will start to change. In the same token, that means that we get away from discrete frequency assignment processes into wider bandwidths that are typically used to ensure that we have network-enabled type capabilities. In yesterday's environment, I had a radio system that was essentially a PRC-77, and it was only a radius type 3-mile radius communication device. But at this point, I can interface it with a network, and it can talk around the world, because the capabilities in today's technology is allowing us to network interface all our systems. That provides a greater capability for the warfighter.
Art, it's great to talk to you. Thanks very much for your time today. I appreciate it.
Thank you. Thank you for having me and giving me the opportunity.
General Gene Renuart is former commander of NORAD and U.S. Northern Command. Welcome, General. It's great to be here, sir.
Great to be here.
One of the huge discussions that I'm having right now with your colleagues still in uniform is the discussion about speed versus inertia in the department. Everybody in uniform that I talk to talks about how we get things faster into the hands of the men and women that need them to fight and deter, versus what the typical process is in the building. What are you seeing? What would you like to see as a way to go more towards speed rather than get stuck in the inertia piece?
Well, I'd love to say we're going to overhaul the acquisition program completely, but that may be inertia too big to overcome. I think there's been some unique tools that the department has taken advantage of over the last maybe 6 or 8 years, and maybe more so now. For example, the use of other transactional authority. So you can I don't want to say bypass the FAR, but you can take advantage of the agility to take money and target it very specifically at a purpose with a deliverable and a timeline that meets the warfighter's demand. And I think using more of that, we're seeing that some now within the department, certainly in the areas of unmanned systems. We saw that in Afghanistan and Iraq with the mine-resistant MRAP vehicles. We've got to take advantage of that and really rekindle what was the industrial base that we had in World War II, where we turned automotive industries into bomber manufacturers. And we can do that. Our country can do that, but that takes some bold decision-making, and Congress has to help with that.
Mm-hmm. You mentioned unmanned systems, and at Soft Week a couple weeks ago, I talked to General Donovan at Southcom, and the discussion about unmanned systems seems to me, not just from my conversation with him, but more broadly, to have gone in a different direction. And that is not so much will we use them or will we not, or how will we use them, but to integration. How do they incorporate into the fleet or inventory that services are already using? What do you see there, and what is an effective way to do that in your opinion?
Well, I think, first of all, I have to, this is very timely because we had 2 helicopter pilots yesterday picked up by an unmanned maritime vessel.
Yes.
That's the first combat search and rescue done by an unmanned system that I know of in our history, our military history. So there's examples, very non-traditional ways that we can use these systems. However, I'm also a traditionalist. You have to have that human brain power coordinating and then exercising the authority to execute a mission based on that that input of capability from a variety of systems, whether they are from space, from an unmanned vehicle, or optical systems that we use, for example, for border security. So the challenge that we have now is to find that process of integration. Some years ago, Link 16 was our way to tie all these communication systems together. We've overloaded Link 16. We need about Link 42. And the reason is the number of inputs that a warfighter has, that a commander of a region like General Donovan has, is growing maybe faster than we've learned to integrate them. And so that's where AI, I think, can really help us. It can process the wheat and the chaff, and it can bring those things out to a decision-making tool that a warfighter can then take advantage of. And that can be down to an iPhone on a battlefield tied to satellite communications that's getting unmanned video that looks over the horizon that tells that infantry platoon who the bad guy is out there. So this is not limited to large systems, but it's really how do we bring that down to the individual soldier warfighter out there in the field.
Do rules and policies and doctrine around unmanned systems look different in your view for a command like NORAD that's focused on the homeland to some degree versus the other organizations in the department that are focused on OCONUS?
I would say it's almost more complicated for that commander NORAD, NORTHCOM. General Guillot has basically from space to the subsurface, from the Hawaiian Islands to Greenland now, from the Arctic to southern Mexico. And when you roll all that in, you have a combination of certainly peer threats out there, to transnational criminal organizations, to migration challenges, to and then dealing with that in a very complex cyber environment that we live in today. His responsibility to protect critical infrastructure touches every one of those. So I think, obviously I'm a little bit prejudiced, but I think that his problem, and certainly mine back then, was maybe more complicated. Rules of engagement have to be clear, they have to be legal, but they also have to be flexible enough that a commander can make some decisions on the fly. For example, as Commander NORAD, I could identify airborne threats or missile threats to the nation, but my rules of engagement to do something about it came through my role as Commander U.S. Northern Command. So from a binational to a U.S. national chain of command, you got to be pretty clear that you and your lawyer and your secretary and your president all understand the different challenges. And of course, for Commander NORAD, it's also the Prime Minister of Canada. You deal with both heads of state. So I think rules of engagement are critically important to us. We have to not lose track of that as we focus on how do we make the warfighter's job easier. We also have to make sure that we protect the innocent, but also protect our relationships with our friends.
We just have about a minute left, but I wonder if there is a special opportunity in the Arctic to use some of these new technologies, given the fact that it's more passable now than it's ever been before, and there's more traffic there now than ever.
Boy, absolutely. And the challenges of operating our traditional comm systems at high north latitudes is really difficult. And yet we're seeing now new developments in technology, electronically scanned satellite antennas that can see up to 80 degrees north latitude. But it's also the very difficult environmental conditions we deal in, the very sensitive environment that we operate in, and the fact that some of our peer competitors out there choose to use that arena as a base for threat. So that's a real challenge, and I'm glad to see that that's been centralized within the Commander NORAD NORTHCOM role so that he can coordinate all of the efforts and deal with the Arctic nations as well.
General, it's great to have you here. Thanks for
My
joining
pleasure.
today.
Good to be here with you.
Brian Clark, Senior Fellow at the Hudson Institute. It's great to see you again, my friend. Thanks for joining me today. A lot of discussion here about integration of autonomous systems into the force. And we talked a little bit before we went on the air about how gratifying it is as I'm watching these things that to see that the conversation doesn't revolve around, hey, we have to go get some autonomous stuff. It's how do we think about autonomy as an important part of, but just part of the fleet.
Yeah, absolutely, Francis. Thanks for having me on. It's great to see you again. The challenge that we're seeing today is not how much money do we have for autonomous systems or which ones to buy. We're sorting out those questions. Now the question is, how do I deploy them into the fleet? How do I integrate them with the operational forces? How do I use them to solve operational problems that the combatant commanders are trying to address? And this gets to some of Admiral Cottle's idea of the tailored forces, which we worked with him on. That's a way of at least making this problem more tractable, right? If I'm going to try to integrate unmanned systems into the entire Navy, that's like boiling the ocean, right? But if I instead say, well, I'm going to put out these tailored forces that use mostly autonomous systems with a few manned systems to do command and control or support, that's more manageable. So let's figure out a way to field these little force packages to address these very narrow operational problems. And we're seeing a lot of progress in terms of designing those and then figuring out how they're going to get deployed. But this is a big question right now is we've got our people that do training and equipping for the submarine force and the surface force and the Air Force. What does it look like for these robotic and autonomous systems?
You mentioned progress. What's driving that progress and what will maintain that momentum in your view?
Well, you've got operational commanders like Admiral Paparo who are yelling for the Navy to deliver on the capabilities to do things like his hellscape idea of having one-way attack drones like we see in Ukraine, being able to defend Taiwan. You've got other countries like Japan is looking at the same thing to say, well, can we use one-way attack drones? They have this shield concept to protect our islands. And you've got Australia looking at how do I use autonomous systems to give me more reach and persistence over the vast area they have to cover with their relatively small military. So you got operational pull, and then you've got the technology push where there's a lot of money flowing into this area. You got a lot of companies that are actively developing these capabilities. And the part that's sort of been missing is the middle, which is Navy people doing what we call force generation. So doing the concept development, the training, the equipping, and then the actual delivery of these systems into the field. That's the part that's missing, and that's what the Navy's been really focused on over the last 3 or 4 months.
I note from my discussions with CNO Caudill that force generation is an integral part of the fighting instructions. And so now that middle has been filled in, it strikes me.
Right. Definitely at the senior level, he recognizes that gap and he wants to apply that standard model, which he calls for force generation, to now robotic and autonomous systems. And I think what the Navy is likely to do is probably give this as basically something that the submarine forces and the surface forces are now charged with is you're generating submarines that are ready to go on deployment. You're generating unmanned undersea vehicles. You're generating, if you're the surface guys, unmanned surface vehicles that go out to these tailored forces. And then the missing part is, well, how do I do the concept development and experimentation? Who's responsible for that? And they're sorting that out right now.
From a cultural perspective, too, it strikes me that one of the things I was fascinated about by the fighting instructions is there are 4 pillars and there's a name attached to each one. So rather than thinking someone in that middle, rather than someone thinking, well, this will happen at some point or someone will do it, there's somebody who will be graded on whether or not any of these aspects happen, including the force generation.
Right, absolutely. He wants there to be accountability, which is not about, punishing people if they fail, but it's more like making sure that somebody feels like they own it and then they can take charge of it. Because I think a lot of times what you see is people feel responsible for it, but they don't feel empowered to go run out and do the actions that need to get done. And so in this force generation area, it's good to see that we're actually empowering people to go be in charge of the development and deployment of these systems. Because until we get that sorted out, we will end up with sort of a stopgap or a barrier that prevents these systems that are being developed from actually reaching the field. They'll kind of bunch up here in CONUS and not get out to the locations overseas where they need to be deployed.
We've talked so far in this conversation mostly on a strategic level. From a tactical perspective, what barriers need to be removed or obstacles overcome to do what you just described, to get these out to sailors and Marines that are on the front lines?
Well, one big problem is contracting. Yes, we've done all this acquisition reform in the department, and one thing we haven't really done is contracting reform. There's new contracting methodologies that are out there, but they aren't really being employed. So the complaint I hear all the time from people on the government side and from the industry side is contracting is too slow. We get someone makes an acquisition decision very quickly, and then it takes forever to get the thing on contract and get money moving to allow us to actually deliver it. The other thing is, getting to this idea of open architecture and allowing systems to play with each other, making it so that you really do have software that you can make interoperable between providers. That's something that's been a roadblock. And so that's been something that's the Navy has sort of stumbled over as they try to field systems in packages like these tailored forces.
The idea of MOSA is something that we've talked about it a lot today, a lot on this program. The hesitation doesn't seem to be from the government side, and it doesn't seem to be from the industry side. So I'm not sure, I guess, where the hesitation is coming from.
It's mostly when you get down to the program manager level and making decisions about what you're demanding of your contractors. So industry is more than happy to make it, available the necessary interfaces so they know how other companies know how to write software against their systems. But it's the government getting in there and enforcing these rules. The Secretary of War had to publish a memo a couple months ago to say all interfaces for software will be published and owned by the government. Well, someone's got to enforce that rule if you want there to be interoperability between these systems. And I've seen a reticence on the part of the program managers to really make that something that's a demand that they enforce and then apply in these contracts.
Brian, there's always more stuff than there is time.
That's
Thank
right.
you for joining me again.
Great to see you, Francis.
George Doherty's former Director of Innovation for C3 and Battle Management at the Air Force and author of Beast in the Machine. Welcome. It's great to have you here. A lot of discussion about the topics that we're talking about at this event, autonomy, AI, robotics, and so on, vis-a-vis Ukraine. Not as much about lessons learned so far from Iran. What are you seeing all over the landscape that leaders currently in the building can take away from what's happening in Iran regarding autonomy, AI, and robotics?
Yeah, well, I think Iran is, for better or worse, a bit of an example of why there is such a sense of urgency around this, right? It still has been, on conventional terms, a tactical victory for the United States, but I think it's been a little bit of a surprise to some, not all, that Iran has actually been able to hit back as well as they have. And that's because they, as well as many other countries around the world, have really been seizing on this first wave, if you will, of smart, highly lethal, but also very cheap and accessible robotic weapons that are coming available in this first wave of the robotic military revolution to level the playing field in ways that we had never encountered before. So they look at it as a way of seizing an asymmetric advantage. They now have something that is potent against even the world's top militaries. So just like Ukraine seized on them to counter and defeat Russian military during their invasion, Iran and its proxies like the Houthis have seized on them as a way to level the playing field with the U.S. Navy and the Air Force and so on, and really give not quite as good as they've gotten, but much better than we would have expected, right? And that's being seen in Iran today with a lot of their ability to hit U.S. airfields, command and control centers, things that have been in the press. But also look at the Houthis. They're part of the Iranian network as well. Just in 2023, 2024, the Navy said that they had been in some of the most intense naval combat since World War II. With who? The Houthis, somebody, not even an entire third world country, right? Just a militia group from Western Yemen who ordinarily think they would be not even a considerable threat at all, and now have the ability to basically to challenge the U.S. and other NATO navies almost on a level playing field, almost. But, we can see if that's the trend, there's going to be a lot of trouble for us throughout the entire world. And so that really lights a fire under everything that we're talking about here at this conference. We can't allow them to erode that advantage to a point that it becomes really dangerous.
The strategic challenge, it strikes me too, is that it's not incumbent on them to have equivalent force projection to an adversary like the United States. They only have to involve that adversary for a sufficient period of time to wear him down. And that appears to be the strategy that the Iranians are undertaking. They know they can't beat the United States. So however long they can keep them engaged using the techniques that you just described seems to be the strategy. Is that a fair read on my
A
part?
very fair read. In fact, I think it's really prescient that I think you're absorbing what not everyone has, which is that a war is still not a robot soccer tournament or a game of checkers where whoever has the most checkers at the end wins, right? The Iranians in this case seem to be reluctant to agree that they have lost. And similarly, we, by traditional standards, easily ran the table in Vietnam, in Afghanistan, and elsewhere. That doesn't necessarily mean that just because you win all the battles or destroy all the targets that you've won the war. So, I think that's going to continue to be even more so going forward. And many of these adversaries, like Iran, like potentially China, certainly Russia, have boasted that they would love to take on the United States on these terms because they point to their awful history of suffering in World War II and going through famines and elsewhere and saying, hey, we can outsuffer the United States. If it comes down to who can take more punches and remain standing, or whose infrastructure can be more devastated and yet everyone hasn't rebelled, they say, we'll take that bet. So you're exactly right. We don't need to lose that much advantage to get to the point that we would prefer not to get into these fights anymore, and we don't want to be deterred in that way.
George, congratulations on the book. Thanks for joining me today.
Well, thank you very much.
George Doherty, author of the book Beast in the Machine on DefenseTech TV, presented by HII Mission Technologies. You can find more conversations like these at DefenseTech.tv. And you can join us next time for more DefenseTech TV. I'm Francis Rose. Thanks for watching.